These are the frequently asked questions for Algebra 2 for Section 8.1, Day 1, where we are talking about rational functions and inverse variation. But a little reminder about direct variation. Direct variation was the relationship y equals kx. Our inverse relationship involves the division model of that, which would be figuring out y equals k divided by x for that inverse relationship. So what we want to see here inside these tables is whether or not this is direct variation or inverse variation. And when you look at the tables, you realize what you're looking at is x and y. So we really want to see what do x and y do together. So if this is direct variation, what we want to do is we want to see if k is by itself, what does this look like? Well, we'd have to divide both sides by x, and that would give us k, which is a constant of variation. That means if we go through these tables and we take the y values and we divide them by the x's, and we're always getting the same number, that this is actually direct variation. And then for inverse variation, we would multiply both sides by x. And in fact, for that, if we took x times y, we would get a constant of variation. So for number 6, it says, is the relationship between the values in each table direct variation, inverse variation, or maybe it's neither one? And then write equations to model the direct and inverse variations. So first thing I would try is direct. So I would take my y value and divide it by x and see whether or not I'm getting some constant of variation. Well, 15 divided by 3 is 5. 40 divided by 8 is 5. 50 divided by 10 is 5. 110 divided by 22 is 5. So in fact, this is direct, because every time I take the y and divide it by the x, I'm getting 5. And 5 is my constant of variation. So this will be y equals 5x, because I want it to look like a direct model when I get done. I know it's direct. What should it look like? Number 7, I try direct first, and so I take 14 and divide it by 3, and I get 14 thirds. Then I take 8.4 and I divide it by 5, and then you want to see what that is as a fraction, and that'll give you 42 over 25. And you realize that's not constant, so it's not direct. Direct did not work. Then we would go to inverse. And remember that if x times y equals some constant, then this is going to be inverse variation. So we would try 3 times 14, and we would get 42. And then we would take 5 times 8.4, and that gives us 42. 7 times 6 is 42. 10.5 times 4 is 42. This is inverse variation. And we want it to look like the inverse variation model. So our constant of variation pretty obviously is 42. This will be y equals 42 over x. And that is our inverse model. Then number 9. Number 9, again, you might try direct first and say, okay, if I take 3 and divide it by 0.1, I get 30. So just trying direct first. If I take 0.1 and I divide it by 3, I get 0.03333 forever. So those are not the same. It's not direct. So then the next thing we would try is inverse variation. For inverse variation, we need to multiply these two together. So for number 9, 3 times 1/10 is 3/10. And for 3 times 1/10 for the second one, it's 3/10. 6 times 0.05 is 3/10. 24 times 0.0125 is 3/10. Now, for some reason, I'm going to write that one as a fraction. So that means these are inverse. This is an inverse variation model. So for this one, I want to write y equals k over x, and my k value is 3/10. Now, you do not put a decimal inside of a fraction. So that means what I have to do here is use a fraction, and then I have to multiply by the reciprocal to get this to look as it should, which is y equals 3 over 10x. Now just looking at the book, I see in number 7 that they had neither. And so I was investigating why on earth would they say that, and it looks like in the second printing of this book, they changed this number, the 14, to a 15, in which case it would not be able to be direct or inverse variation for the model. So if your chart has 3 and 15 as the first ordered pair, then 5 and 8.4, then 7, 6, and 10.5 and 4, you have to put neither for number 7. Depends on which printing of the book you would have there. Next up, we have, suppose that x and y vary inversely. Write a function that models each inverse variation and graph the function and find y when x equals 10. So 14, if it's inverse variation, has to fit this model, y equals k over x. And for 14, they're telling me that y is going to be 3 and x is going to be 1.2. Now, you know how I am about decimals inside fractions. So 1.2 I would think of as 1 and 2/10, which is 1 and 1/5, and then I would change that into 6/5 right away. And then we don't divide by fractions, we multiply by the reciprocal. But in this case, you take a look at this and you realize all I have to do is get rid of the 6/5. So to get rid of dividing by 6/5, I just have to multiply by 6/5. This isn't a situation where we're trying to move something over to the other side. We're trying to eliminate. And so in this case, we'll get 18/5 for k. So this will be y equals 18/5 over x, which again is not okay. So we're going to go ahead and make that look right here. So this will be 18/5 multiplied by the reciprocal 1 over x, which will be 18 over 5x for our model for number 14. Now, once we have the model, what we need to do here is graph it. It said graph the function and find y when x equals 10. So what I need to see is just a couple of points on the left-hand side and a couple of points on the right-hand side of this graph. So maybe try -2 and -1, and then maybe 1 and 2, because we know these are going to be hyperbolas. We just need to put some numbers in there. And when we're graphing, it's perfectly okay to think decimals. So 18 divided by 5 times -2 is -10, and that's going to give us a -1.8. And then we go on and try a -1 in there, and we have 18 divided by -5. And again, you might want to go ahead and put that in as a decimal, -3.6. Go ahead and put a 1 in there, so this time it'll be 18 divided by +5, and you see the symmetry. Put a 2 in there, and you have 18 divided by 10, which is 1.8. So now what we need to do is just get those two hyperbolic branches on here. So at -2, we have -1.8, and at -1, we have -3.6. Let's scoot this up a little bit so that you can see all of that. And then for the other branch, 1 3.6 and 2 1.8 because of symmetry. And there are our two hyperbolic branches. So that was number 14. I chose that one because of the fractions within fractions positions that we see everything up there. And last but not least, there was a request up here that we find y when x is 10. So we're going to put 18 over 5 times 10, which is 18/50ths, which reduces to 9/25ths. And they did give you that one as a decimal, 0.36. It's the same thing as 9/25ths, but I certainly would prefer the fraction in that case. All right, then number 17, you have to remember they're trying to save on type space. We don't care whether or not we're using type space, we want our answer to be elegant. So in number 17, we start again with the inverse variation. And this time y is a negative 1/3 when x is 5. And so in this case, if I want to know what k is, I would multiply both sides by 5. So I get a negative 5/3 for k. Now that has to be substituted back in. So y equals negative 5/3, all divided by x. But again, we're going to multiply by the reciprocal, which is going to bring that x down to our denominator. So y will equal a negative 5/3x. Now we want to see what does that hyperbola look like. So once again, let's put in our own standbys here on each side of the y-axis. So if we put negative 2 in for x, we'll have negative 5 over negative 6, which is 5/6. And you could make it into a decimal if you wanted to for graphing purposes. A negative 1 in for x, 3 times negative 1 is negative 3, 5 divided by negative 3, negative 5 divided by negative 3 is 5/3. Then we put a 1 in there, and that would give us 3 times 1 is 3, so that's going to be negative 5/3. No shock there as we see the symmetry. You put a 2 in and you get negative 5/6. So we need to graph number 17 at negative 2, 5/6. At negative 1, 1 2/3, and then at 1, negative 1 2/3, and 2, negative 5/6. And then again, draw in those branches with the asymptotes of the x and y axis. And then finally, they want to know if you put a 10 in for x, what would you get? So if we put a 10 in, that'll make that negative 5/30ths, which is going to be a negative 1/6 for the y value. So that's the last piece of that one. And again, I'm trying to do the ones that have the more complicated fractions going on up here, but we should really be more comfortable with fractions than we are. So for number 18, y equals k over x, we have negative 105 equals k over negative 4/15. Again, we are trying to solve for k. We're not just trying to move something over. So we are going to multiply by negative 4/15 because right now they're dividing by negative 4/15. And that will give us our k value. So if we take our 105 times 4, and that's just because the two negatives we know are going to make it a positive, and divide that by 15, we will get 28 for k. So the one that looks like it's going to be difficult for us because the fractions involved actually comes out very, very nicely to y equals 28 over x. And again, we want to try negative 2, negative 1, 1 and 2, see the symmetry as we go through this. 28 divided by negative 2 would be negative 14. 28 divided by negative 1 would be negative 28. And we can see that's really low already. And then a positive 1 will give us 28, and a positive 2 would give us 14. So what we might want to do with this one is see, what's going on with a number like 3, or in this case, I would probably even go with 4, because 28 divided by 4 will give you 7. So we'll see that 4, 7. Because that number up in there for k is 28, that's telling us that this is going to pull away a lot from 0, 0. It pulls away a lot from the origin. So in this case, what we might want to do is go by 2s, go by 4s, go by something that would help us see this a little bit better. So I think what I will do is go by 4s this time. So we'll have negative 2 and negative 14. And then negative 1, negative 28. And then, like I said before, we know what's going to happen with that hyperbola as we go in there. And if this is on a test, I would probably put in a -4 and see what's going on and those type of things. Because if we put a -4 up in here, we're going to get a -7. So 1, 2, 3, 4, about there. Go after all this again now. So there's my -2, -14. My smartboard is just a little bit off, and I really don't like that. All right, and again, because of symmetry, we'll see equal but opposite on the other side here. And there it is. And then if we put a 10 in for x, y will equal 28/10, which is 14/5, because they wanted that 10 in there. All right, basic hyperbolas that we looked at there. Then at the end of this assignment, some review on graphing absolute value. We haven't seen that in a long time. So what we have to remember is our generic formula for absolute value. And it's just good old A, H, and K again. So for number 59, I noticed that A is a 1. And I know it's hard to remember this far back, but that is the slope of the right side of an absolute value graph. And absolute value graphs are V-shapes. So the parent function for this is going to be just the absolute value of x, which is that perfect V-shape with diagonals through first and second quadrant. However, this has a k value, so that means I need to take those points and I need to move them 2 up. And then connect that up into a V-shape. So that's number 59. Graph the equation, describe the transformation, shift up 2 because of a k value. Then for number 60, I again see the parent function without an h and k is just going to be y equals 1 absolute value of x. So that's still vertex at 0, 0, going through 1, 1, 2, 2, -1, 1, -2, 2, etc. First and third quadrant perfect diagonal. But this time I have an h value and it's -2. And that means I'm going to have to shift this 2 to the left. And so we see the exact same graph, but it has just been shifted 2 units to the left. Number 63 has both an h and a k value. But again, our parent function is that perfect diagonal through first and third quadrant, and that's because the a value here is still a 1. So what I have to do is recognize that h is -4 and k is -5. So this is going to shift 4 units left and 5 units down. So really what I need to do is I need to move my vertex 4 to the left and 5 down. But the slope of my right side of my graph is still +1. And then equal but opposite on the other side because of symmetry. And there it is. So good review of graphing absolute value functions. And that will do that. Now, I think that was it. Let me double check. That's it for this one.